So I will be talking about syncing Flux stores across clients. All right. So quickly before I start, anyone who would be interested, just try hitting this URL. It's a little demo, a sample app I threw together last night, which uses the stuff that I'm going to talk about today. And I will get back to the demo towards the middle of the presentation. All right. So the spelling is like Flux and the Ocket part of socket. So Flux socket -chat.herokuapp.com. Cool. All right. With that out of the way, my name is Abhinav Rastogi. You can find me on Twitter and GitHub with these IDs. And I have flown here from India for this conference. I work at a company called Flipkart, which is the largest e-commerce player in India. So we are working there with, my team is working with React, Flux, React Native, and these sort of technologies around for the past 1 year. And it has been a really good experience so far. So what we have realized is React and Flux work beautifully together to create an organized application for a client-server architecture where a client talks to the server. You throw in the React router, and you can make amazing single-page applications which are fully client-side. One issue here is that these are designed to work as independent clients. Not an issue as such, but a limitation. What happens if you need these clients to communicate with each other? So there can be many examples of these things. You could have chat applications, auction applications, task management, collaborative note-taking maybe. These are situations where all your clients need to be in exact synchrony with each other. You need to show the same state across all machines. Now, maintaining this consistency can get cumbersome very easily. You need to sync data over the wire. The obvious solution would be that you could share the entire state on every change. Any client makes any action, and any user takes any action on your website, you could just tell what the current state is, send it back to the server, and share it to all the clients. Some obvious optimizations over that could be that you diff the data, and then you send the delta changes over the network, which is a very good network optimization. For this, Flux comes to the rescue. Now, as we all know, Flux is a very simple way to represent delta changes. What I mean by that is, let me take an example. So Redux is a really good example of what I'm trying to say. It represents stores. It uses stores to represent state as a reduction of actions, which means that it effectively stores only delta changes, and whenever you want to read the current state of your application, you simply apply those delta changes over some initial state, and you can get to the final state. What Flux enforces is just one thing. That's one-way data flow. And it follows a fire and forget approach. All you need to implement Flux is an async system where stores can modify consumers on change and actions can notify consumers on dispatch. Now, the key word here is asynchronous. Right? How do you do asynchronous in JavaScript? Right? It's a very old problem. So there are many ways to do this. The obvious being events. Right? Or you can do callbacks. You can do generators. You can do sockets. Right? But how do you exactly do that? So this is what a Flux action dispatch looks like. Okay. Seem to be stuck. Okay, all right. So this is what a Flux action dispatch looks like, right? You pass some action name, and you have some data associated with the action. And together, this forms something that we call the payload, which is also similar to how events work. You have an event name, you have some data associated with it, and it's also similar to callbacks, which is how a dispatcher, the Facebook dispatcher internally implements it, where it maintains all the registered callbacks and simply calls them when you get the associated action. So who else has a similar signature, right? So interestingly, sockets also follow a very similar thing, an event-based system. You pass an event name, you pass some data to it, and that's how messages get passed from the client to the server and vice versa. So a very obvious realization at this stage is that what if you can pass Flux actions over sockets, right? You could take an action. So whenever you fire an action, on the client from, so suppose you dispatch an action from your view on the client side. Simultaneously, you could also make a socket, you could pass a socket event to the server who broadcasts it to the other clients, and then you could have a similar logic in all your components where they listen onto the socket changes, and when those actions happen, they could fire their actions locally. So let's take a look at how Flux, how we can optimize this a little further. So this is what a typical Flux flow looks like, right? So key things to note here would be that all mutations happen only via actions, and all actions go through the dispatcher. So a very interesting thing that comes up here is that, and a very interesting thing we could do here is that we could pass all the actions from the dispatcher to the socket. Right? So the dispatcher looks like a very promising place to add this logic. So what if the dispatcher could internally handle all the syncing? So what I thought was that maybe you could have the dispatchers talking to each other, connecting to each other via, you could have the dispatchers talking to each other via the sockets through the server. So a client could emit some actions, talk to the server, and that happens. Let me dig into this a little deeper. So what I propose is that you have a dispatcher. When you fire an action to the dispatcher, it not only dispatches it internally to the registered callbacks, it also emits the same action over the socket to the server. The server then receives it and then broadcasts it to all the other clients except the one who sent it. And this is made very trivial by socket.io. Then the dispatcher or other clients could simply listen to those socket events and dispatch it as a local action. So the obvious benefit here is that your views are blissfully unaware of all the action that is going on. So this is exactly what I implemented in a little sample that in a little repo that I call as Flux socket. I'm still looking for better names. So it's just Flux over sockets. So this is the URL. You can hit it and check out the code, which I will just talk about a bit more in a moment. So as I said, if any of you have tried out the URL that I gave you in the beginning, it's a very simple chat application, right? All it does is, let me see if I can pull it up. Okay, all right, we have some action going on here. So, okay, so it's a very simple chat application. On the client side, all it does is you have a simple text box, you have a button, you hit the button, it just takes the value of the text box, fires a Flux action, and on that Flux, on the store change, it just simply re-renders the list of messages there. Now, the interesting thing here is that all these messages need to be synced to the server and to other clients. So what I did was I created this dispatcher which acts as a drop-in replacement for the Facebook dispatcher. And this syncs to other clients without a single line of code change to the app that I just described. Okay, let me go back to my slides. Cool, okay. So there is a very interesting gotcha that I ran into when I tried to do this. All right. So what the dispatcher does internally is, what I need to do internally is that I emit all the actions over sockets, and any events that I receive over the sockets need to be passed as actions or dispatched as actions to the local store. What this can lead to is an over-the-network loop. What I mean by that is, suppose you are user A on that chat application. You enter a message, it gets the action is raised, the store changes, and it reflects immediately on your system. The dispatcher also fires a socket event to the server, goes to user B sees it as an action, again dispatches it to local system, and also passes it back over the socket to the server again. And the same message is sent back to user A. What this leads to is, as I said, an over-the-network loop. So one solution that I thought could be, right. So one solution that I thought could be that you would need either an application logic change or an API change. You could maybe add a socket ID to recognize that maybe the dispatcher should realize that it should not fire events, it should not fire socket events for the messages which are generated from the same socket ID it is residing on. But as I said, that may require a change in application logic. But I thought that my requirements are that it should be a drop-in replacement and there should be no external API change. So at this point, I would like to point this out, that if you treat the action dispatch and the callback as two separate entities, this problem can be solved very easily. If anything, there should be one key takeaway from this talk, that you can treat the action dispatch and the actual callback as two separate entities within the dispatcher. Right? You can get in between these two events, where you actually raise the action from the view and where it gets dispatched to the stores. You can intercept this and make changes there, which is where I added my logic to fire it over the sockets and keep a check. So this is what I did. To the dispatch command, to the dispatch function, along with the payload, I added a broadcast flag, which, as you can see, has a default parameter of true, which is made possible by ES6, elegant JS, right? So what this default value allows you to do is it allows the external API to be the same. Any applications which don't use this broadcast flag automatically treat it as just a dispatch with a payload, and it automatically shares all the actions to the client, but to the server and to other clients. But what you can do here is, interestingly, is that it allows you to keep some actions private, right? You can pass a broadcast false, and it will not fire those actions to other clients. This means you can selectively sync some actions to all other clients, and you can keep some actions as private. So let me talk a bit about how I internally implemented this. Okay. So as you can see at the top, I have a set socket function, which is an API I'm still working on. So I create a socket in my component as a global from socket.io, and I have to pass it to the dispatcher in the beginning of at the start of the application. It keeps that socket, it keeps a reference of that socket, and also adds an event handler if I pass a Flux action over from the server to it, which it dispatches as a local action. Similarly, the dispatch function, as I already told you, if you pass the broadcast flag as true, which is the default value, it gets emitted over sockets. And it has to return the actual dispatch call with the payload so that you still have access to the dispatch token. So, interestingly, this is not a very new concept. Right? A similar work has been done by Elle Rotengerg. I think he talked about it in Paris. His talk was called Flux over the wire. But it was slightly different than this. So what he did was he fires the actions from the client. He dispatches the action from the client with the call, and that dispatch goes to the server. And the callback is actually triggered from the server over the socket, which means the server is responsible for making updates even locally, which means you do not get optimistic updates. With the approach that I just talked about, you get optimistic updates. Your interface updates immediately, and the other clients update as and when they receive actions. And with this approach, the possibilities are endless. Right? So let me give an example. Right? You just saw the chat application. What is happening there is that all the actions that you take on the website, right, any interactions you do, are going to the server. What you can do on the server is, that's one thing I tried. Maybe you could just dump all that data, all the actions in Elasticsearch, run Kibana over it, and you have got something like a free real user monitoring. So this is something I tried. In the chat application you're looking, I just posted some of the common, I took some popular speeches of Martin Luther King and some other like Abraham Lincoln, and I just threw the speeches into the system. And this is the kind of data analysis that I could do, that these speeches have some common words like nation and grand and pledge and things like that. So it gives you a very easy way to actually monitor what your users are doing in real time. And yes, because it's Elasticsearch, you get full text search and real-time graphs over your data. Another example that I can show you is a small game that I tried using Canvas and WebGL using React. So let me see if I can get an actual demo working for this. Okay, so here's one window, and there's another window. Okay, let me try here. Cool, here we are. So this is something that it allows you to do out of the box. So if I have, okay, let's reload this. What? Okay. Cool. So yeah, so all I'm doing here is taking the current user's position and putting it on the canvas locally. And by the virtue of using this dispatcher that I just talked about, it automatically syncs to all of the clients over the network, which allows you to make multiplayer games very easily. So yeah, that's pretty much it. And okay, you can't see my slides. Yeah, just a second. Yep, that's all. Having some troubles with the project. Thank you.